Docker builds can feel like watching paint dry. But what if you could shave 90% off your build time every single time? Rebuilding a large Docker image from scratch is agonizingly slow. Every command re-executes, even for unchanged code, wasting precious minutes and compute cycles. Docker Layer Caching is an optimization that reuses previous build steps. It works by treating each instruction in your Docker file as a separate, immutable layer. If a layer hasn't changed, Docker just grabs the pre-built version instead of rerunning the command. Step 1. Docker File Parsing. Docker Engine first reads your Docker file from top to bottom. It breaks the file into individual instructions like from, run, copy, and cmd. Step 2. Layer Creation. Each instruction in the Docker file generates a new layer in the image. For example, run apt-get update creates one layer, and copy /app creates another. Step 3. Cache Key Generation. For each instruction, Docker computes a unique cache key. This key combines the instruction itself and the content of any files it references. For run commands, the key is the command string. For copy commands, it's the command string plus a checksum of the copied files. Step 4. Cache Lookup. Before executing an instruction, Docker checks its local build cache. It looks for a previously built layer whose cache key exactly matches the current instruction's key. Step 5. Cache Hit. If a matching layer is found, Docker performs a cache hit. It skips executing the instruction and immediately reuses that pre-existing layer. This is indicated by using cache in the build output. Step 6. Cache Mississippi. If no matching layer is found, Docker performs a cache miss. It executes the instruction, creating a brand new layer. This new layer is then added to the build cache for future use. Step 7. Cache Invalidation. The critical rule: once a cache miss occurs, all subsequent layers in the Docker file after that point are invalidated. Even if their instructions haven't changed, Docker will rebuild them. This ensures image consistency. Step 8. Content Addressability. Docker uses content addressable storage for layers. This means each layer is identified by a cryptographic hash of its contents. If even 1 byte changes in a file copied into a layer, its hash changes, leading to a cache miss. Imagine a Docker file, from node 18, copy package.json, run npm install, copy, cmd, npm, start. If you only change a file other than package.json or packagelock.json, Docker will reuse the from, copy package.json, and run npm install layers. Only the copy layer and subsequent ones will rebuild, saving minutes on npm install. Many think copy should always be at the top. This is wrong. Place copy instructions for stable files, like package.json or requirements.txt, higher up. Place copy for frequently changing application code lower. This maximizes cache hits for expensive dependency installs. Order your Docker file instructions from least to most frequently changing to maximize layer cache reuse. I break down how real tech like this actually works every single day. Subscribe to Tech with Joel and tell me, what's your biggest Docker build headache? Subscribe to Tech with Joel.